All right. And good morning, everybody. Nice you could be here. Hope you had a pleasant night at Oslo. I did for sure. This talk is going to be about continuous integration and delivery. In respect of my work, I work currently at Lego, which probably all of you know. I have a background as a .NET developer. I've been working with various companies. I've started out at Just Eat, which was actually founded here in Oslo, if you didn't know. I didn't earn any money on it, others did, but not me. But it's quite a fun journey anyway. And then I've been at eBay and a non-profit organization, and before I came at Lego. I'm not the best programmer out there, and I'll come back to that, because I attended a session yesterday where two guys were from Microsoft, from the ASP.NET core team, were talking about how they were optimizing the inner workings and memory allocation and stuff like that in terms of getting the ASP.NET core to perform better. I'm not that kind of programmer. That's not me. That's not what I do. I'm much better at pattern recognition and trying to understand the what in things, and I'll come back to that later on. I like automating things, and I tend to have a pragmatic approach towards things. This session will cover a little bit of background in respect of what I do at Lego and what Lego is all about. How do I fit in the larger scheme of things in Lego, because it's an enterprise organization with 17,000 employees. And I think you need that background in order to understand the problems that me and the team I'm part of are trying to solve. So I'll just touch upon that. Then a bit upon security. What is security? When you talk security, people have their own subjective feeling on what security is, but I think we need to elaborate a bit on what security is in terms of understanding how to implement security in the solutions that we're about to provide. And then finally, from the trenches. I've collected a few examples of what we've done, my experiences from the past, failures I've made, others made. All of them probably had something to do with providing cake in the end and a retrospective. And there will be code. It's funny because this is a developer conference, and if you were project managers and some people tend to fill up an entire day's work with meetings and writing agendas and stuff like that and running around in circles, and nothing gets produced. The shoulders kind of meets on top of their head when they see that there will be code. So it's kind of funny to see from up here when that happens. Your developers, shoulders down, please. There will be code. And that's okay. So, Lego. What is Lego, in essence? We have behind, if you go to www.lego.com, you'll end up seeing this, the front page of our website. It's actually around 180 websites, and we support 25 languages. In our last annual report, we stated that we have almost 20 million unique visitors per month. We have a YouTube channel with 1.3 billion visitors, or actions, or however you measure it, in 2015. We measure things in millions and billions, so it's quite a large website. We make apps, lots of them, apps for kids. We have some very clever people who are able to write and produce apps for kids who hardly can speak. They can't spell. They don't know the words. They don't know the letters. But even so, they're actually able to navigate and play a game and have a good experience in it. I don't know how they do it, the guys who make the apps and stuff, but they're very clever. And we do that a lot. And games, of course. Each website is a product. And a product could be the Ninjago site, or the City site, or the Star Wars site, or whatever site. There's a few examples of them here. And we have, in terms of how they are produced, we have product teams in India responsible for given sites. We may have a city product, and a team in India and Denmark are responsible for maintaining and implementing features on the city side, as well as the Angry Birds side, as well as the Friends side and Elf sites, etc., etc. Behind the product teams, which are very product focused, they just churn out code in terms of the product that they're responsible for. We have a platform teams, and they work on a global level. They provide NuGet packages for our Sitecore CMS platform, for instance. These sites are built on Sitecore. And we have platform teams responsible for the Sitecore. We have a team which are entirely focused on tracking, for instance. And we have a team responsible for, well, they produce things and gimmicks for app development as well. They're kind of more horizontally focused, where product teams are strictly vertical. They can have several verticals that they're responsible for. And then we have a system team, which is me, with friends. We manage all this by using Safe. By all means, I'm no expert in Safe. You're welcome to come ask me about Safe if you're interested. Safe is Scaled Agile Framework for Enterprises. The guy who invented Scrum, in its sense, he wrote a book about it and became quite a de facto author of what Scrum is. Mike Cohen, I think it was. He wrote a book and held a lot of courses and earned a bucket of money. And then enterprises started to pick up. And 10 years has passed, and he wrote another book about Scrum for enterprises and made a bucket of money, and that's where we are today. That's called Safe. It's essentially how you scale Scrum teams in enterprise organizations. That's what we do. I think it works for us. It has drawbacks, of course, everything does, but we have the numbers to prove that their work satisfaction and the visibility in when 20 teams are working together, the dependency mappings and how risks are being escalated. It works much better than before Safe was introduced into our organization. So come ask me, please, but no detailed questions on release trains and stuff like that. This is a system team. There's me. I have no idea why I ended up being the two-headed eagle or two-headed snake. I don't know. Then we have a guy named Alberto, he's Italian, he knows about embedded programming. Then we have Michael, who's actually sitting right over there. White shirt. Hi, Michael. Who's Barbosa, I think, from Pirates of the Caribbean. Yeah. Michael he knows about SQL and stuff like that. Casper knows about test automation, testing things, and he knows about .NET development as well, just like I do. I regard myself as being the developer who knows how developers think, how they act, their core values and stuff like that. Not that the others don't know, but that's my background. And then we have a guy named Jonas who is more an architect, has an architectural background and is able to read 2,000 pages in a book and actually remember those 2,000 pages. I can't do that either. We have a product owner with swords and knives fighting the rest of the business, fighting them off, I think. If something needs to be prioritized, go to him. If business wants something, needs something, grooming needs to be done, go to Yannick. And then we have our self-proclaimed snowplow who is trying to mingle things with the organization, and he is our manager. He proclaims himself to be a snowplow and tries to remove impediments and stuff like that. What we do in the system team, we are responsible for everything below the platform teams, from the platform teams and down. We are responsible for our source repositories, for instance. We have the responsibility for our static code analysis tools, everything that all the other teams are using, both platform teams and product teams. And we are also responsible for the build and deployment pipeline, because that is something all the other teams are using as well, including platform teams. So we are the foundation of the mother of everything, actually. It's a fun place to be in, because you get to know a lot of things, and that's where I fit in, because when you have so much knowledge about how the business is working on a horizontal level, you start to see patterns emerging. You can't see them when you are in a product team and you're just churning out code and you have a Sitecore website and you have very strict deadlines. You just need to get things done. But in order of being able to change things, you need insight from all the product teams and the platform teams, and in order to be able to see where the friction is and how to improve the build pipeline. You can't do that by being in a product team. So I fit in very nicely where I belong right now. That's what we do in the system team. We do automation. We actually, you can say that we're just maintaining and providing features for an assembly line. People stuff in code at one end, and magic happens, and you end up having an artifact which you can put in a package, put it in stock, and deliver somewhere else at the end of the pipeline. That's what we do. A large part of what we do is also to provide APIs for the developers. We try to enable them to be creative, to do what they think is right for the task at hand. We try not to be a constraint. At some point we are a constraint because in terms governance contradicts total freedom and to do what you want. And we need governance in terms of security. I'll come back to that. So sometimes we are perceived as being a constraint, but we try not to be. We want to enable our developers in all the teams to be self-serviced, for instance, and be able to do whatever they want. And we've come quite far, but we're not there yet. Because we are located where we are, bearing the foundation of everything, there's also a support process where if you have a problem and you don't know where to go, come to us. And because when I started a year and a half back, we had people were running around in circles because they didn't know where to go if they had a problem with which nobody owned, with a product that nobody owned, or how do I get access to this system that nobody really wants to touch? Every enterprise have them. So, and people started running off to Michael. He almost never did anything else than supporting people and didn't have time for features because being a supporter is a rewarding place to be in. Everybody likes a fireman. You come out and put out the fire and people are happy, they walk off again with a good experience. But it doesn't help the business very much. You don't have time to implement features and help the business in the long run. You just put out fires all the time. In the system team, we decided to swim lane all the task switching involved and call it the DS developer support, DS for digital solutions, which is the department I'm part of. So 1 week at a time, we have support, and there's one guy doing all the task switching, and all the other guys are working on the assembly line, implementing features. Come ask me about how to do support. I think we have good reasoning behind the things that we're doing, but that's not the focus for now. That'll be a totally different talk then. These are just, on the top of my head, the technologies that we need to know a little bit about, all of us. Some of us need to know the how about technology. Some of us need to know how to set up Git, how Git works, or HTML, or Amazon Web Services, Mac, Perl, whatever. But we all in system team need to know where each of these technologies fit in, and technologies emerge every day. Developers, when you enable developers to think independently, they start to be creative. They are uncontrollable. I know I'm one of them. And you need to keep an open mind, essentially, to be able to work in the system team. It's not for everybody. And you have to be quite clever, I think, in terms of being able to keep up. I don't know a lot about Node.js, for instance, but I know it's something we use heavily. I don't know how you do it, but I have quite a good feeling of what it is and how it fits in, for an example. Lego has grown dramatically during the past years. And we have growing pains right now. We're transitioning into a global organization. And in terms of scalability, that causes growing pains. The solutions we implement and the examples I provide to you afterwards is an example of how we try to provide solutions that scale. If we take technical debt, for instance, when implementing a solution, we might implement a solution or implement a feature with a certain amount of technical debt or manual labor involved. And that's okay, but we have to consider that Lego in 2 or 3 or 5 years will maybe be twice as big. So the manual labor we introduce today might be a magnitude of 2 or 4 times in just a few years from now if we grow in the expected growth rate. How do we utilize offline resources? How do we scale the organization and implement IT for the organization, which is also scaling? That is one of the major pain points, to nail that one right. And errors do happen, but we try to, and the paradigm of giving people the responsibility is a major cultural change, because before, when you have maybe 8 or 10 or 12 teams, you can, and you know every team that that are working for you, you can be a dictator in many senses. That doesn't work anymore when you have 25 or 35 teams, or maybe 40 or 50 teams in a few years from now. I think now we have about 25 teams, and we're growing rapidly. So we have to provide infrastructure and organizational units and to enable them to work effectively today as well as in 2 years from now. So, a little bit about Lego. On security. Security is immensely important. I don't think anybody disagrees. But what is security in itself? How do we define security? In terms of Lego, Lego is one of the most powerful brands out there in terms of trustworthiness, loyalty. There's a company called Brand Finance, I think it is, that measures and rates all large companies throughout the world, rate them against each other, and Lego has been in the top 10 for 8 or 10 years, I think. In the terms of loyalty, trustworthiness, etc., 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 they have lots and lots of parameters to measure upon, and that comes from somewhere. In terms of what we do, and in terms of preventing data leakage, we need to ensure that people trust Lego, because we're not selling Lego boxes to kids, we're selling Lego boxes to their parents. And if they don't trust Lego to be able to ensure the safety of their child's data, they won't buy anything from us, or that we are unable to earn as much money as we do on selling Lego boxes as we do. We also have multiple IPs, intellectual property owners, that enable us to build Star Wars Lego. Star Wars is owned by Disney, for instance, and we have a strategic partnership with Disney that enables us to build Star Wars Lego. If we have a data leakage, if we for somehow compromise data that falls back on Disney somehow, we might not be able to build Star Wars Lego anymore. We might not be able to do that, and that will have a, shall we say, huge impact on what Lego is able to do. Also, we can't trust all our employees. We have 17,000 of them. So, what do you do? How do you? That sense of security is important to us, but how do we implement it in our everyday? How do we begin doing that? And back to basics. In our everyday, you're in a meeting. You're in a meeting with, might be grooming a new feature, you have your stakeholders, and you have non-technical staff there. And you start talking, we want this and we want that, and I would like to have, etc., etc., etc. And somebody starts questioning, are we safe? How do we ensure that this solution is safe? In terms of how do we protect our data? Can we tell our users that, how do marketing tell our users that we are safe? And somebody stands up and says, what if I told you that we have used a specific encryption algorithm? And everybody dies a little in that room. It just doesn't work very well. Energy leaves, just evaporates. Because you have a technical guy who's not talking at eyes height with the non-technical stakeholders that you have, and you need to protect your stakeholders from guys like that. I'm one of those guys. It happens all the time, but nevertheless, it's important to try to talk in language that your stakeholders can understand. So you don't say Greendale and AES and stuff like that to your stakeholders. They don't understand you. And because you're the technical expert, nobody dares to question or say, can you explain in human language what you actually mean? It's very rare to experience project managers and stakeholders who are just marketing people, whatever, questioning a developer on whatever the developer says because he's the expert. He makes things happen. I'm sure you can recognize meetings like that. If you are in if you have technically savvy people present at the meeting, of course it's okay to talk tech stuff. Of course it is. But we need to propose an alternative for the people who are responsible and we want to be accountable for security, but don't know about encryption algorithms. We need to propose an alternative. So instead, he should have said this. We have secrets. And we have a happy stakeholder. Because everybody knows the concept of a secret. It's just wording, but it's immensely important, I think. Trying to get people to understand what is happening, what is the inner workings of the features that we are providing. If we have secrets, a secret is a secret is a secret. That's what it is. You don't have to elaborate on it. You don't have to talk any more about it. It's just a concept. People are smiling. Why is this funny? It's because I have a son. He's 10 years old, and he was looking over my shoulder when I was preparing for this event. And he sat for a while, and we came to this slide, and he looked and he said, "That's just plain stupid." And he's 10 years old, and so he understands. He's 10 years old. He understands. He doesn't even know what I'm doing and what I'm working on and why I'm going to Norway. But he understands this image because the absurdity is so obvious. Wouldn't it be rewarding in a fantastic, sensational way if we could talk about security with our stakeholders in terms of images like that? If they could understand that what they are asking for is essentially this, that a solution that doesn't solve anything. Security by obfuscation, for instance, is just exactly that image. But people don't get it if they, even if they don't know tech stuff, they might not get it. And we are responsible for providing them with the information in a context they know and can take into account. We're the only ones who can do it. And the end goal should be for them to take ownership of the security features within their solution. So I have a proposal for you on the next slide. Oh yeah, the part that I wanted to elaborate on is that there are terms from domain-driven design. It's been eons since I read the book. It's from Eric Evans, who wrote about domain-driven design, coined the term. He said that you need to build a ubiquitous language, which is a shared language between the developers and stakeholders, and everybody onboarded on a project should use the same terms within the domain of whatever they're trying to accomplish. What have we used in terms of security? That security is wall building. You have an asset on one side, you have a threat on the other side. You want to protect the asset, so you build a wall. It's a concept easily understood. Everybody knows what a wall is. Just look at the image. They had barbarians on one side. They kept flooding the whatever Ming dynasty was at 3,000 years ago. So they built a wall 3,000 kilometers long, and problem solved. Boom. And we need to be able to explain to our stakeholders and to ourselves that what we are trying to do is wall building. And then you can start having a discussion where to build those walls. How high should they be? Do they need to have barbed wire on the top, for instance? Do we need to have crocodiles in a dent outside and landmines and whatever? Or do we just need a fence, maybe a meter high, because it's not that big a threat? Or it's just very, very rare that we're even going to be exposed, and a wall that high, made out of wood, would be perfectly fine. There's a gotcha, there's a catch 22, I think it's called. I found some numbers in a report. It's from 2007. If you look at that image, you have assets, you have threats, you build a wall. It's very clear where the threat is located. People tend to forget that threats very often emerge from the inside. So you can build all the walls you want, but you need to build walls and establish procedures within your castle as well. You can't just say that you've locked everybody out efficiently and now you're safe. That's one of the most common misconceptions I could think of. The Panama Papers, for instance, I think they had security in their organization. I don't know if they still exist. That Mossack Fonseca had the proper procedures. They needed to log in every morning when they went out to work. But still, they were compromised. They had a data leakage for the benefit of everybody in this room, I think. But they had customers, and I don't think their trustworthiness is very high at the moment at their customers. Edward Snowden is another example. NSA do have procedures and data, and they know stuff, but data was leaked anyway. So take this into account when discussing where to build the walls. It's very important that you don't underestimate where the threats are located and how security breaches happen. I haven't read the entire report. I have to do it, even though it's 10 years old. I think those numbers still apply for today. What we have to keep in mind when discussing security, in order to enable stakeholders to take ownership, is to keep technology out of the equation. Once you start talking security in terms of the technologies on this slide, and you are trying to explain something to people who are not aware of technologies, they might not know what ASP.NET is and Git and how Perl and Puppet fit into the image, you've lost your stakeholder, and you've essentially lost a very important part of being in a project and team building and all sorts of things. You need to keep technology out of the equation on a high level in order to establish that ubiquitous language, which is so important when you have technical and non-technical people trying to gain a common understanding of the problem at hand. There's a funny story to this one. It was actually Michael who was, we were sitting at a planning meeting. We have bi-monthly planning sessions as part of SAFE, and we were bored, I think, just a bit. And we started discussing how you could explain what security is and how you do not apply security. And you do not build a solution and then, like baking a cake, you can't just provide it as a topping afterwards. You need to bake it into the cake. And because I think the meeting stopped a bit early because lack of energy and whatever, so I went down to and shopped, and we built this the day after. And you would be surprised how many project managers in general, everybody, both developers and non-developers, have commented on that exact image. All the illities that we know of, scalability, usability, security, but you can't. It's hard to explain why they're important to plan for. But that image, I think we actually got to somebody just by building that. It took maybe an hour, and I think I've brought it as an example today because it just worked. It was immensely important in terms of getting people to understand, providing them with an image that they can use to when stories needed to be prioritized, for instance. A developer asked me if this rules out declarative tags in code. Of course it doesn't. It was a good question, but it does not. Because you just need to plan for scalability and security and all the illities. You need to plan for them ahead. You can apply them in different fashions. That's not really the point here. You just need to plan for them and not forget them and take them into account every time. That's what that image is trying to tell. All right. From the trenches. Usually at user groups, and if I'm giving talks there, I tend to take questions, but come to me afterwards. I'd be happy to answer everything, and if I can, I'll just point to Michael and run away. All right. Down to basics. You have a secret. This is an example of a secrets file. I just made them up. Homer Simpson doesn't work for Lego, by the way. This could be a file with secrets. It could be any configuration file out there. How many of you have checked in files into source repositories with secrets in it, usernames, passwords, etc.? I think everybody has, yes. And it's wrong, because then it's not a secret anymore. And you probably don't know who had access to those secrets and did they take them with them? Did they take a copy of that file? Where are your secrets today? So in order to protect secrets like that, we always say, check everything belongs in the source repository. It's a fundamental term in everything that we do. Infrastructure as code and everything as code and code. But if you want to protect your secrets, Scott Hanselman wrote about it, and he said that essentially in order to protect them, you need to keep them out of your source control and out of your source repository. And I think he's right. Because you can't protect anything that you've checked in and shared. Source repositories contradict the concept of keeping secrets a secret, because source repositories are essentially sharing text files. And so you don't want them in there. Stop doing it. I still do it, but I shouldn't do it. So, I'll try to provide an example that how do you avoid checking in secrets into your source repositories? And this is a very low-key example. I was thinking about what is the minimal viable product? What is the absolutely least you can do in order to get your secrets, protect them, get them out of source repository, but still have a means of deploying them in a fairly decent fashion. And this will work in continuous integration and continuous delivery scenarios as well. Of course, there are drawbacks, but essentially, if you do nothing today, if you just check it in and everything works, you should do something, or you should try to convince your fellow colleagues that you need to do something. What you can do, and I'm turning 180 degrees, if you can create a source repository which you can lock down and lock down good, that means you know exactly who has access to it, and you can prevent anybody from peeking into it. You can create a source repository. Otherwise, you don't. And create your secrets in whatever format that you like. Plain text is fine. You can encrypt them if you want, but how do you protect the keys used for encryption? If they are available on the server, right? If you have an encrypted file and the key right next to it with a plain text password, you're why encrypt it? But if you have a source repository, that's fine. If you don't, then don't. You can just have a shared folder and add permissions. Add permissions on that share, and then you know who have access to it. So you do that. You create your secrets in a file share somewhere. You might want to invent a convention for your files. This is just out of my head, something like that. And then from that, you push your files to your application servers. This is very low key. This will work for startups, small companies. It's not enterprisey. It has drawbacks. How do your copy function? Does it copy over a secure line, for instance? Do you open up for man-in-the-middle attacks, etc., etc., etc.? There are many attack vectors here, but in terms of governance, this is much, much better than having nothing at all. And then you need to refactor your source code to look for and expect to find a secrets file at your desired location. And for the love of God, do not put all secrets in one file, because you will, when you copy that file, and if you break the schema or something happens so your code is unable to read that file and every secret is in one file, you just obliterated all your applications. I've been there. It's not fun. And so don't do that. You can, by creating and maintaining some sort of convention towards the products and the things that you want to store secrets for, you're in a much better place. And it scales immensely well as well. Why do you want to provide secrets for applications who don't need them, for instance? Why do they need to get access and be aware of secrets they are never going to use? So split it up, separate files. This is a connection string for just an example. There's a user ID and a password in there. It's a regular SQL user account. And it is eternally... there are a number of drawbacks that I'd like to show you, because when you see that at first, it's not a problem, you think. But what happens if you have a data leakage? If you leak data and you want to roll your passwords? What happens is that you are unable to roll your password. You have locked yourself down entirely, because that username and that password has been distributed across 50 applications. So you need to change 50 applications in order to change your password. And that's hideous and not very fun from a security perspective. You essentially rule out these two use cases. You're unable to solve them if you provide your secrets to your applications in terms of connection strings like that. You are unable to set up automation in creating a database, for instance, because your configuration file needs secrets. And you are unable to roll passwords for application and databases. If you have security procedures and audits, stuff like that, they might propose that you roll passwords on a schedule every 3 months, perhaps, 90 days. And that's a good practice. And that enforces better code. Better in terms of narrowing down the attack vectors and your ability to handle accordingly if you leak data. So, how to solve it? You need an API. Some users are sitting to the left. They talk and interact with an API in order to gain access to their secrets. And you have auditability and everything in a database somewhere. This applies to many systems. There are third-party vendors out there who, we have one at Lego, where we store our secrets. Active Directory fits nicely into this image as well. You can interact with Active Directory through PowerShell, that's your API. So you can create users and get users and role passwords and whatever. One thing you have to keep in mind, this is the very abstract image of what you need to do. You need to interact with an API. And what you need to be sure of is that if you have an API and you provide your secrets, you want to make sure that the secrets and audit database is sure, because if you are compromised, what would prevent a hacker from changing your audit logs as well if your database is not secure? I would do that if I was a hacker. I would take all your secrets and delete every trace of me ever being there. But that's just me. That's what I would do. So you need to have auditability on the API and on the data that you're trying to store. Please don't roll your own, unless you're working for a company who are providing that exact functionality. Hackers are so clever, and unless you're really, really, really good at security, this is spyware. Basically, that's what I'm trying to say. Don't roll your own. And most of you, you're mostly founded in a in a Microsoft and .NET world, so you have Active Directory. It works very well, very well. Go in that direction before going somewhere else. So we have a developer. He wants to create a database. Oh, he's part of a build and deployment pipeline. Maybe he's deploying a website for the very first time. So he built it, the build is green, a deployment kicks off, and somewhere along the line, the build pipeline figures that it has no database. So we need to create a database. How do we do that? How do we shield off secrets from the developer? He shouldn't provide any secrets at all, but we need to create a database and provide credentials for login, authentication, authorization for that database without the developer being aware. How do we do that with an API? Well, first we create some secrets. The build and deployment pipeline needs to interact with the API, and it needs to have proper authorization to be able to create secrets as well. How your API gets access to creating secrets, that's entirely up to you. But it's an important factor to keep in mind that somewhere along the line you need to build in trust in your build and deployment pipeline in order for it to interact very intimately with your secret store. That's a feature in itself. How do you narrow down the attack vectors? How do you not open up your build and deployment pipeline for intrusions and how to explain it? How do you ensure that your build and deployment pipeline is not open for attacks because it is able to interact with your secret store? Keep that in mind. I just put up post, and there's a convention based, and I'm creating an administrative user. That's the example I'm trying to provide. So it's created. A database is created from a vanilla database, or an image or something like that. And then the build pipeline applies authorization for that admin user. It gets the user just being created. It's only the developer doesn't do anything. And then a script, you can provide, the build pipeline provides a script, fires a script against the new database being created, the db-foo, with a user and a password that the developer is completely unaware of. That's how you do it. This is an SQL user. If it was an Active Directory user, the the code would be different, bear in mind. But this is just to give you an example, a hint on how you shield off your developer from getting to know secrets he should be totally unaware of, and how to automate your pipeline, and still being able to create databases and stuff that needs secrets, but still maintaining that you want 100% automation, and you want you to shield off developers from stuff that he shouldn't know anything about, to protect him as well as you. And the build pipeline goes on. Secrets in various environments, they differ. Secrets in dev and QA and live and whatever environment you have, they might change. They should be different. And this pipeline, the example here, applies or enables different environments to have different secrets. So, that's one use case, automation. That was the first one from the slide, a few slides back. Another one is, which is very common in what we are trying to accomplish at LEGO, is that a developer needs access to a secret during his deployment. We don't want that in source control, but he needs it. It could be a certificate for AWS deployment. It could be a username password for creating a website. It could be, well, find your own example. It could be anything, but we need to provide him with secrets in a secure fashion, and we don't want them in source control. He's not supposed to check in those secrets into source control. How do you do it? Use an API. Any questions? No. What we have is that we have a system administrator. It could be the developer. It might not. At LEGO we have a different department. I'm with digital solutions, and somewhere over there, in a completely different part of the organization, somebody is paying for our AWS accounts, for instance. Just an example. So he needs to create secrets which effectively is being paid with a certain cost center somewhere, so it ends up on the correct account. So it could be that system administrator who creates the secrets for the build and deployment pipeline. Or it could be the developer just tabbing it into a system somewhere else, but it's a different role. We need to distinguish the two. So secrets are being created and made available for the build and deployment pipeline. Then, along the way, we made a feature which unlocks those secrets during the deployment pipeline, and we made what I later came to know as essentially we just built it, and somebody pointed out that we made a template pattern. I'm not familiar with patterns, maybe 15 years ago when I was studying, but this is a template pattern. We're doing a lot of housekeeping and firing off a script that the developer owns. They are the proud owners of their own deployments. They just need to respect a certain contract that our deployment pipeline enforces. And one of them is that we have a parameter where we store, they get access to unencrypted secrets. Yes, unencrypted, because they need them unencrypted in order to, for instance, create a new website using PowerShell. They have a convention for getting access to that secret. They know if they obey that convention, they can get access, that specific access from secret from this list, this item. I want the username or the password or whatever. So by obeying the convention, they can get access to secrets. So we provide them with a PowerShell object, which for them to use. And this is enabling them to be creative. They can request somebody to create them to create secrets for them, or they can create them themselves, and they can write their own deployment script. If they want files deployed differently in different environments, go do. They don't have to interact with us. They just write code and make it happen. But we still have governance. We are able to roll that password if we want to. It's immensely strong. I think I'm quite happy about it, actually. So, right, final example. This is a part of our deployment pipeline. And this is an example of what happened when we performed the security audit on the template pattern we just implemented here. We have people in LEGO who knows immensely much about security, and thank God for them. They are very helpful in terms of nailing down the weakest part of the link in the things that we do, because we're developers. We think in sunshine scenarios, and when things working, hey, we're happy. And then comes a security audit. And user stories start to emerge. What we have here is that we have a step where we extract keys from our secure store. That's the unlocking, the chain lock, which is being unlocked on this image. That's this one. And then we have the deployment script being invoked at that step. And then he started, our security auditor, he asked what happens in the middle? How does secrets get from the step above to the deployment script in the bottom? Oh, well, we just store it as a property and boom. We just have unencrypted secrets in our log files in every other step between those two arrows. Available for everybody with read access to that deployment pipeline to use and see, and we're screwed. So what we had to do, and we never thought about that. We just, hey, it works for us. Our users are happy, they can use it, but we weren't finished. And it's important to reiterate and think in non-sunshine scenarios. Have people help you uncover that. You don't open up for. You can do so much, but if we had left unencrypted secrets in our deployment pipelines and in our log files, we hadn't accomplished anything. And this is the level of security we need when being a company like LEGO, because if we have too many of those, essentially someday we've lost, and I think we'll get compromised. So we need to keep a high standard. What we had to do here was to encrypt the keys that we just extracted with a credential that nobody is aware of. That's a functionality embedded in the workflow engine, which is deploying code. It can create a credential for you that you're totally unaware of. So we can use that to encrypt the secrets we just extracted and decrypt it in the deployment step. So even us, the administrators of our deployment pipeline, cannot see. We can just see a base 64 encoded string, that's all. That's how we solve that particular problem. And that's the standard that you need to have in order to ensure and show to the world that we're doing our very best, our utmost. Experienced people are working on ensuring your kids' data within our systems. Final note, I think it's quite funny, but you can over-engineer so much when you're doing security, and you need to challenge assumptions all the time. That's basically what I'm trying to say with that image, because you can do security within a year, but try to keep in mind which walls you're trying to build. And this one poses, again, you don't do that, ever. I will find you and hunt you and kill you with a spoon if you do, slowly. So please don't. I'm quite aware that many developers at LEGO will probably watch this, so I know who you are. I can find you. You own the deploy script, so I can see who checked in last. Yes. All right. Security is all about removing harm and ensuring trust. That's what it is. If you ever need to explain what security is, use those terms and elaborate upon it. You should build walls the right size and in the right place. And have a discussion about where to build the walls. How high should they be? How wide should they be? Do you need to build in cannons and guns and crocodiles and stuff? I haven't touched much upon auditing, but if you can show how people interact in your systems, who is accessing secrets, how they're being accessed, which systems have access to which parts of your system, you're in a very good place. I have an example of, Michael is probably smiling now, where I rolled a password for a worker account, which effectively shut down our pipeline. It took my team 30 seconds to look into the logs and see that I was the one who had last made the update. And yes, I had to buy cake in that respect. But it's immensely important that you think in terms of, you think in audibility and visualize and make it transparent who's accessing secrets, both systems as well as people. Who's reading secrets is equally important as who's updating them. Never underestimate peer pressure. I will never forget to double check and triple check that I've got the right account the next time I roll something, for sure. Get your stakeholders on board. Try to create a shared language for a company. It's Agile Manifesto. It's not banalities, but it's been around for eons, for decades. It's important. Don't forget. If you start a project, start with a security feature, because walking skeletons win. By starting with security, you will be forced to start integrating stuff together. If you have a totally greenfield application, you should kick off and start with the login function, for instance. Or whatever function interacts with various parts of your system where security is involved. If you need to exchange certificates, start with that. As well as if you're in doubt, do a security feature. It will uncover where to build your walls, and proof of concepts will test if you're building your walls in the correct fashion. And eventually you'll get a good dialogue kicked off by doing the security features first if you don't know where to start. Penetration tests provide great value. Just bear in mind that they should be the kickstarter of a dialogue. It's not just we have so many errors, 72 errors, go fix, now we're safe. That doesn't work that way, then you're doing it wrong. But it can be, they will find something all the time. These companies, that's what they do for a living. Trying to penetrate systems and show you a report, and they're very, very good at it. You can buy systems for a few $100s and just run them internally, and that's a good place to start. You don't have to get people to do it for you. You can you can come pretty far by doing it yourself, but getting somebody from the outside to do it, they will have a totally different perspective of your infrastructure than you have, because you're cluttered in it and work with it every day. So you don't see the weak points the way that an eventual attacker will do it. Simple is often more secure. And if you're in doubt, if you make things too complex, too hard to understand, you're also probably opening up attack vectors that you're unaware of. So the simple solution for distributing secrets, for instance, is better, even though it has numerous drawbacks. It's better than doing nothing, and you can overcomplify things in a way that you're actually better off not doing anything at all. That's all I have for you. Please remember to vote. I appreciate the feedback, and I know the conference does as well. And come to me if you have questions. Thank you.